We need to find out the percentage loss of pre-stress due to anchorage slip of 5 mm. No, loss of strain is equal to anchorage slip by length of the beam, that is equal to 5 mm by 40 into 1000, because 40 meters and we are converting it to mm. Value is 1.25 into 10 to the power of minus 4, and we know initial stress and modulus of elasticity. Modulus of elasticity is equal to stress by strain. Initial stress by initial strain. Initial strain is equal to 2 by 2.1 into 10 square, that is equal to 9.524 into 10 to the power of minus 3. Therefore, percentage loss of pre-stress, percentage loss is equal to loss in loss of strain by initial strain, that is equal to 1.25 into 10 to the power of minus 4 by 9.52 into 10 to the power of minus 3, 1.31 percentage. So option D is correct. Now we have to find out the maximum compressive stress in the concrete. Maximum compressive stress, we will consider it as W, that is equal to P by A plus PE by Z, where P is force, pre-stressing force, A is cross-sectional area of the beam, and E is eccentricity, and Z is sectional modulus. We have to know Z. Z is equal to BD square by 6. B we know, D we know. So by substituting P 500 kilonewtons and A 300 into 500, E is equal to eccentricity of the beam, that is equal to 100 mm. So the maximum compressive strength, we will get it as 7.33 Newton per millimeter square. We have to be very careful about the units. All dimensions has to be in a single format. So answer B is correct. From the question, you will list out the data that was given. A sample of saturated cohesionless soil. So C is equal to 0. Tested in a drain triaxial compression test. Showed an angle of internal friction phi is equal to 30 degrees. The deviatoric stress at failure for the sample at a confining pressure of 350 kPa. Confining pressure sigma 3 350 kPa. We have to find out sigma D. For that we need sigma 1. Sigma 1. What is the relationship between sigma 1 and sigma 3? Sigma 1 is equal to sigma 3 tan square alpha f plus 2c tan alpha f, where alpha f is equal to 45 plus 5 by 2, that is equal to 45 plus 15, that is equal to 60 degrees. So C is equal to 0. Substituting C is equal to 0, this term is going to be 0. Sigma 1 is equal to sigma 3 is 350 kPa tan square 60, that is equal to 3 into 350, that is equal to 1050 kPa. But we need to find out sigma D. Sigma D is equal to sigma 1 minus sigma 3. We know sigma 1 and sigma 3, the difference directly going to give us the deviatoric stress, that is equal to 700 kPa. So answer B is correct. For a heavy compaction, the energy imparted, heavy compaction, the energy imparted is equal to that 5 92 kilojoules per cubic meter. And for standard Proctor test, we have to find out the energy imparted and footing area of 0.25 square meters, and it is having a thickness of 500 mm, that is 0.5 meters. Therefore, the energy imparted, required energy is equal to 592 by 4, that is equal to 148 number of blows, and 50% of energy, more energy in each pass over the compacted area. Because of the overlap, 50% of more energy is consumed. So required number of blows for 50% more energy is equal to 0.5 into 148, that is equal to 74 numbers. Answer C is correct. Here in this problem, what we have to find out the rotational speed for a 1:2 model. Given data, we will consider model as M and prototype as P. What is the relationship between rotational speed and the head causing flow? N M dm by root hm is equal to np dp by root hp. In the problem, we know that dm by dp is equal to 1 by 2 and hm is equal to hp is equal to 20 meters. It was given. Directly substituting these values over here, we will get these things are going to be cancelled. Nm by np is equal to 2 and nm is equal to 2 into 500, that is equal to 1000 rpm. 1000 rpm is option A. Option A is correct.